All right, so what we're going to be talking about in this very brief lecture, hopefully, is just get some official notes down on the slope-intercept form of a line. We've studied the standard form of the line, ax plus by equals c, which is great. It's a usable form of a line, but y equals mx plus b slope-intercept, I think, is going to be a little more helpful, right? So basically, anything is in slope-intercept form it's if it is or can be written in the form y equals mx plus b. And really, m is the slope of the line, and b is the y-intercept. So you know where it hits the y, and then you know the slope of the line. It actually gives you a fair bit. Basically, anything you have, any linear equation that has y solved for, y by itself on one side of the equal sign, is in slope-intercept form. So if we're taking a look, we've got three equations here that are written in slope-intercept form because y is by itself. And if we want to figure out what the slope is of this first one, 4x plus 7. What is being multiplied by x? 4. Or you could say 4 over 1 if you want to see it as a fraction. Sometimes that's helpful. And then the y-intercept is whatever is the constant, so that would be the 7, or if we wanted to write it as an ordered pair, it would be 0, 7, because the y-intercept has an x value of 0, an x-coordinate of 0. The second one has a slope of 3/4. The slope had a good breakup. It hangs out with its x, right? So whatever's being multiplied by x is your slope. This one has a y-intercept. Its value is 0. You can't say it doesn't hit the y-intercept. If it has a slope of 3/4, it's going to hit the y-axis at some point. And we wouldn't ever write it like this, but we could, and it wouldn't, change anything. So the y-intercept there is the origin, is 0. And then this last one, that is in slope-intercept form, and you know that the slope has a value of 0 because there is no x. And what caused that x to disappear? Well, we multiplied it by 0. So the slope is 0, and the y-intercept is -3. So if there's only an x term and no constant term, you know that the y-intercept is 0. If there's only a constant term and no x term, then you know that the slope is 0. But any linear equation where you have y by itself on one side, no exponents other than 1, you have something that's in slope-intercept form. Now, what we can now do is say, all right, well, what if we have the slope and the y-intercept? Can we write an equation? It's actually very, very easy. If you have that information, however you get it, whether it's given to you or whether you figure it out from a graph, if you can tell where it hits the y-axis and what the slope is, you can very easily create the equation for the line that has that information. So this first one, and the slope is 2 and the y-intercept is -1. So it's going to be y equals 2x. 2 is the slope, so I'm going to multiply that by x, plus -1. If you want, or that's the same as 2x minus 1 as well. You could write that the same way. You could write that same equation. Okay? The slope is -3/5 in the second one. And it's probably a good idea just to put the negative sign with either the numerator or the denominator. It doesn't matter. 3/5 times x plus 4. There's your equation. You know a little bit of information. -3/5 is the slope, and 4 is the y-intercept, and you get the entire equation, which you could then plug into a calculator or a computer or whatever. So you can take a very little bit of information and get something pretty handy. So another way to do that same thing that we just did is to look at a graph and determine the equation of that line. So as I'm looking at this one over here, I know that my slope is going to be negative because the line is going downhill. So I've got to figure out the m. I'm going to figure out the b. I'm actually going to go a little bit backwards. I'm not going to find the m first. I'm going to find the b. And I can see that it hits the y-axis at 2. So the y-intercept is 0, 2, or just 2 in our formula. Then we have to figure out our slope. So how do we get from this point, in this case the y-intercept, down to another point on the line? Well, I can look at this one right here and say, well, there's another point that's clearly identifiable. So to get from, I'll call this point A to point B, I had to go down 2. Right? So my change in y is 2, or negative 2. And my change in x is a positive 3. I know that because I knew the line was going downhill, so I knew that my overall slope was going to be negative. So my change in y is negative 2, positive 3. So my equation is negative 2/3 x plus 2. And lastly, how can we graph the equation if we know the formula? Well, knowing those two things, knowing that the slope in this case is negative 3 and the y-intercept in this case is positive 2, that gives us everything we need to know. So the first thing we're going to do is we're going to plot the y-intercept. So I'll put a point right here. Then I just want to speak to that. We should always start by plotting any point that we know is on the line. We know in this case that the y-intercept is on the line. If you're given just some random point anywhere on the line, plot that one first, and then proceed with the next step. So really, step 1 should be plot any known points. We know that the point 0, 2, or 2 is the y-intercept, so that we can plot. But if we know any points, we should plot that information. We should plot that point. Then, from that y-intercept or the known point, move according to the slope. So this slope really is negative 3 over 1. So if I start at this point and go down 3, because my rise is negative, 1, 2, 3, and over 1 in the positive, that's 1 point right there. Always do it more than once. 1, 2, 3, over 1, there we have it. And it should be, I'll do it even one more time. 1, 2, 3, I've got the room, right? If you do it a bunch of times and it all lines up, it's probably safe to say that you haven't made any sort of mistake. Right? And if we draw a line through that, extend it out forever and ever, there's the line that we have. I'll even put arrows on it because people like seeing the arrows. So if you are given the equation and you need to get it on the coordinate plane, start by plotting either the y-intercept if you have the equation, or any known point, and then move according to the slope a couple times. And this is really why we want to keep we talked early on about keeping slope as a fraction. We want to see it as an up and down move and a side to side move. That's what we want to do. So that's why we want to keep it like that for this situation here. If we had a different slope, not this one in particular, but if we had a different slope that could be written as a decimal, it wouldn't make much help. There wouldn't be much help graphing this line. Right? So this form of a line, the slope-intercept form of the line, y equals mx plus b, is super helpful, super useful because you can get a lot of information from it really easily. You can create graphs from it really easily. And it is going to come in really handy when we start plugging things into program like GeoGebra or anything like that, or a graphing calculator. It's really built for y equals mx plus b. So hopefully you're able to fill out the note sheet for this. Please let me know if you have any questions. Do that practice worksheet that follows, and I hope this helped.